Okay, here's some problems that I think can be a little bit tricky sometimes. So the key to these is to make sure that you take as much time as you need. Really go slow on these types of problems and identify exactly what we're looking for and exactly what you've been given. In order to write an equation of a line parallel or perpendicular, one of the major keys is to identify whether you're using parallel or perpendicular lines in this case. I would always tell my students, go ahead, read the problem, write the equation of the line perpendicular to y equals negative 4x plus 1 that passes through the point negative 1, 6. Write the answer in point-slope form. Right off the bat, the two most important pieces of information I see in here are things that I would circle or highlight or underline, and that is that you need perpendicular here. And recall, perpendicular means that the slope has to be the opposite reciprocal. I would go ahead and write those things down on every problem if that's a perpendicular line. It's important for you to visualize exactly what you're going to be doing. The next most important thing is in bold here. You want to write your answer in point-slope form. If you don't know what point-slope form is, that's going to be a big problem. Sometimes we'll have you write it in point-slope form. Sometimes we'll have you write it in slope-intercept form. Go ahead and write down what point-slope form is. Y minus y1 equals m times x minus x1. Once you get your answer in that form, you're done. There is no more steps. Once you know and you've identified exactly what you're looking for, write down what you need. You need to know the slope of your current line. Because you're writing the perpendicular line, you're going to need to know the slope perpendicular, which we've been doing is identifying slopes, parallel slopes, and perpendicular slopes. So you'll need to identify the perpendicular slope, and you're going to be writing your new equation through this given point. So you're going to use your perpendicular slope with the point negative 1, 6 in this case. Okay, these two pieces of information here are going to be used to write your new line in point-slope form. So as I look back, the equation I'm given is y equals negative 4x plus 1. I'm going to write that down. That's my current line. It is already in slope-intercept form, so I can identify the slope. The slope in this case is negative 4. Because I want perpendicular slope, it needs to be the opposite reciprocal of negative 4. The opposite of a negative 4 is positive 4, so my new slope will be positive. The reciprocal of 4 is 1 over 4. So my new slope is 1/4. Now that I have my new slope and I know the point, I can write my line in point-slope form. Remember, this first y is always going to be there. I set the table. I have these three blanks, 1, 2, 3, that need to get filled. Well, 1/4 is my slope, that goes in front of my parentheses. Negative 1 is my x coordinate, that goes with my x value. Because it would be a minus a negative, we make that a plus 1. My y coordinate is 6, that goes with my y variable. I now have my equation written in point-slope form. When it says point-slope form, we're happy. We have no more work to do. My major work is done in this section right here, and then filling this in. I'm done. I don't have to solve for y. The only time we solve for y if it says slope-intercept form. Moving on to our next example. It says, write the equation of the line parallel to y plus 3 equals 3/5 times x plus 2 that passes through the point 15, comma, negative 2. Write the answer in slope-intercept form. So again, I'm going to go through and identify my important pieces of information. First of all, parallel. Circle either the word parallel or perpendicular in every problem of these. Parallel means you will use the same slope. Okay, the next most important piece of information here is the form they want you to write this in. Slope-intercept form. That's y equals mx plus b. Right away I should know that I need to do this in 2 steps. If I have to write it in slope-intercept form, I have two steps. First, write it in point-slope form. The second step is solve for y. Solving for y is what puts this into slope-intercept form for us. So, I need my slope, I need my parallel slope, I know my point, it's 15, -2. From here, I can do step 1. This line is in point-slope form. These numbers mean nothing to me. 3 and 2 don't mean anything if it's already in point-slope form. The important number is what the slope is. I've identified that. It's 3/5. So my slope is 3/5, which means that the slope of any line parallel to that is also 3/5. Once I have my parallel slope and I know my line, I can now do step 1. Step 1 is to write this in point-slope form. So y minus my y coordinate is going to be equal to my slope times x minus my x coordinate. I fill in my blanks. My y coordinate is -2, so I make this +2. My slope is 3/5. My x coordinate is 15. That's step 1. I have not answered this question yet because it says to put this in slope-intercept form, I need to solve for y. That's my last step here. Solving this for y, remember, simplify both sides first. This side is simplified. Y plus 2 equals, this side I have to distribute. So I have 3/5 times x, 3/5 times -15. When I multiply that, I get a -9. Okay. I'm not quite done yet. I have one step left. I have to move this 2 over by subtracting 2 from both sides. And y equals 3/5 x minus 11. That's my final answer. I have now written a new line, a new equation of my new line in slope-intercept form.